All right, guys, this is section 4.1. The title is Sampling and Surveys. So, a couple vocabulary terms we need to know here. It says the population in a statistical study is the entire group of individuals about which we want information. Okay, and a population doesn't have to be like population of people. It's just a population of whatever variable we're talking about. Okay, it could be cats, it could be people, it could be the weights of something, heights, it could be a lot of different things. Okay, and the way we collect information about everybody is called a census. Okay, so if it is people, like in the United States, the government collects a census once every 10 years. They collect information about all people in the U.S. every 10 years. Okay, that's actually part of the Constitution. They have to. Okay, so that's how we collect data from every individual in the population. Okay, but a lot of times it's not feasible to take a census because it takes too much time and it costs too much money. So instead of getting information about everybody, sometimes it's a lot more effective just to take a sample. Okay, so a sample is the part of the population from which we actually collect information. So let's say we take a sample of 100 people, 100 adults. Okay, well then those 100 adults, that sample can give us information about population really. Okay, so it says we use information from a sample to draw conclusions. Okay, so we take those 100 people, and we make conclusions about everybody from those 100 people. Okay, to plan a sample survey, you must first say exactly what population we want to describe. Then you state exactly what you want to measure. Okay, so let's look at a few examples. So in these examples, identify the population and sample in each of the following settings. Okay, so it says, number one, the student government at a high school surveys 100 of the students at the school to get their opinions about a change to the bell schedule. Well, clearly there's more than 100 students at the high school. So the population would be, okay, the population would be all students in the high school. That's everybody. And our sample are the 100 students, okay, the 100 students that we measure information about. So we're going to use these 100 students to speak for all students. Number two, the quality control manager at a bottling company selects a sample of 10 cans from the production line every hour to see if the volume of the soda is within acceptable limits. So let's start here with sample this time. Okay, the sample is the 10 cans that are selected each hour. And what's being measured? The volume of soda. Okay, that's what's being measured. And what do those 10 cans give us information about? Well, it gives us information about the population of all cans of soda produced at the bottling company. So the next part of the text kind of goes over some things that you shouldn't do when you're taking samples. So there's a certain type of sample is called a convenience sample. Okay. It chooses individuals from the population who are easy to reach. So for instance, if you go down the street and you want to know how all Americans feel about a certain topic, maybe it's politics, a convenience sample just maybe you just go out and ask the first 10 people that you meet or the first 100 people you meet. That's called a convenience sample. Okay, because it's convenient to do, but the information you get might not be representative of the entire population. Okay, so think of convenience sample as something that's really easy to do, but the information you get from it might not be representative. Okay. Now this other term, there's another term called bias. All right, the design of a statistical study shows bias if it would consistently underestimate or consistently overestimate the value you want to know. So for instance, if you wanted to know what the average income or the average salary of the typical American is, and your sample only contained professional athletes, that would be a sample that has bias, because what you're getting, if you just choose professional athletes to sample, it's going to consistently overestimate the value of salary that we want to know, because professional athletes are paid way more than the typical American. Okay. And then another type of sample is called a voluntary response sample. Consists of people who choose themselves by responding to a general invitation. So a lot of times where you see this is like in news programs. If you watch television and you watch the news, if the news asks you to give your opinion on something like a poll, do you favor this or that? They give people the choice to be in the sample by responding to maybe a social media invite or a telephone number to call and give your opinion, or an online poll. The only people that respond to those are usually people that have strong opinions either way. So if it's something like your opinion on abortion, you're not going to get the middle people, you're going to get people that are passionate on either side. Okay, so that's why that's not a good sampling technique, because people choose themselves to be in the sample. All right. Now sometimes that's not bad if it's done under certain controlled settings, and we'll get into that a little bit more. So let's look at the next example. In May 2010, the LA City Council voted to ban most travel and contracts with the state of Arizona to protest Arizona's new immigration enforcement law. The LA Times conducted an online poll that gives us some information that asked if the city council was right to pass a boycott of Arizona. The results showed that 96% of the 41,068 people in the sample said no. So it says, what type of sample did the LA Times use? Well, people had a choice to be in here. If they participated, they went online and voted. Okay, so the type of sample here would be a voluntary response sample. Okay. So number 4, it says, does this result, so does this 96% result, does it represent the opinions of all LA residents? Okay, well, the only way to get the opinion of all LA residents would be to ask all LA residents. So we could say no. This sample only represents a very small portion of LA residents. To find all LA residents' opinions, we would need to take a census. So even if the sampling method was better, it's still not going to represent all the opinions of everybody, because we need a census to do that. We would need to have data on the entire population. Explain how this sampling method could lead to bias in the results. So with online polls, with some voluntary response samples, usually the people that respond to those they have very strong opinions. Okay. So how could it lead to bias? Well, first off, to participate in this poll, you have to have online access. Maybe some people don't have online access. All right, so it just says explain how the sampling could lead to bias. Okay, and I would say something like this. Voluntary response samples usually only get people with very strong opinions on issues, or on this issue in particular, because immigration, it's a hot topic that's going on for the last, I don't know, 20 years or so. All right, so if you're talking about illegal immigration, then that's a very people that are really passionate on this issue. So let's read the question again. So LA City Council voted to ban most travel on contracts with the state of Arizona to protest Arizona's new immigration enforcement law. All right, and then they said, is the city council right to put this ban into place? And most people said no. So they think the city council should not have banned Arizona. So the people that are saying that think that LA should just continue to do business with Arizona despite their immigration enforcement law. So it's, it could lead to bias because we only have people that have very strong opinions on this issue. And that's true for most voluntary response samples. So now that we've talked about sampling badly, let's talk about sampling well. So one principle of sampling well involves random sampling. Okay, that involves using some sort of chance process to determine which members of a population are included in the sample. Okay, and the best type of random sampling is called a simple random sample. Okay, so what that is a simple random sample of size n is chosen in such a way that every group of n individuals in the population has an equal chance to be selected as the sample. There are several ways to choose an SRS. The numbers in a hat method are by using random numbers in a table or generated by technology such as your calculator. Okay, so what that means, let's say that, okay, in the US there's about 320 million people. Now, the best type of sample that we could draw, let's say we wanted a sample of 100 of those 320 million people. The best way to do that is assign all 320 million people, or put their names into a hat. It'd have to be a pretty big hat, little slips of paper, and then you're basically just going to draw 100 of them. Draw 100 names out of a hat. Or put a number next to everybody's name, okay? Then use technology to pick 100 random numbers, and then ask those 100 people whose numbers had been chosen, okay, next to their name, and ask them whatever you want to ask them. So that would be the best type of sampling. So let's look at the next example. All right, it says the management company of a local mall plans to survey a random sample. Okay, so here's our sample information. Random sample of 3 stores from the 21 listed below. to determine the hours they would like to stay open during the holiday season. Okay. So we have, I just put them in alphabetical order here. Now there are two famous footwear stores in this mall for whatever reason. Okay, so I'm going to label this famous footwear 1 and famous footwear 2. Okay. So before we do anything, let's assign a number to each of these stores. So I'm going to call Aeropostale number 1. Okay, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And actually, I'm going to, since we have some 2-digit numbers here, all the ones that start with a single digit, I'm going to put 0 in front of them. Okay. 14, 15, 16, 17, 18, 19, 20, and 21. Okay. It says use the random digit table in your book, starting at line 111, to select an SRS of 3 stores. So in your textbook in the back, there's a table. It's a table of random digits. All right. I'm just going to go to that. All right. So here's the random digit table. It's table D. If I start looking, if I start on line 111, I'm just going to write down the first few numbers in that table. All right. So in table D, starting on line 111, I just picked that at random. The numbers start 81486, 69487, 60, 513, 09297, 00412, 71238, 27649, 39950. So those are the numbers in that row. All right. So all of my stores have 2-digit numbers. Okay. So we're going to start here, and we're going to break these off into 2-digit numbers. And the 3 goes with the 0, then 92, 97, 00, 41, 27, 12, 38, 27, 64, 93, 99, and 50. All right. Well, I don't see any store that has 81 next to it, so we're going to ignore that one. I don't see any store with 48. Okay, the highest number I have is 21. I don't see any 66, so I'm going to eliminate that. I don't see any 94. I don't see any 87. No 60, no 51, no 30, no 92, no 97. If I started my numbers at 00, then I would get one, but I chose to start my numbers at 01. So there's no store that's 00. There's no store that's 41. There's no store that's 27. But I do have a store that's 12. Okay. So Gymboree is a store that we can use. And I have 38. There's no 38. There's no 27. There's no 64. There's no 93. There's no 99. And there's no 50. So I only have one store when I started at that. So what I have to do, I have to go to the next row in my table. All right, so the next row in my table, 59, this is row 112, 59, 63, 68, 88, but then I do get a 4. I get 04. So that would be the next one I can use. 04, Barnes & Noble. Okay, Barnes & Noble is 4. And then there's another 4, but we've already chosen 4, so this is a repeat. So I'm going to eliminate that one. All right, I can't use 59, 63, 68, 88. Can't use 4 again. Then I have 63, which I can't use. 47, which I can't use. And then I finally get 11, which I can use. There's 11. There's footlocker. Okay, so that's how I use a random number table, random digit table. All right, I chose the 111 at random. I assigned all of these numbers before I started the process, so it's a chance process. It's a random process that I used. All right, so my 3 stores would be Barnes and Noble, who I labeled number 4. I have Foot Locker, who was number 11, and Gymboree, which is 12. Now, because you have some numbers that didn't get chosen because we only had 21 stores, it can take you a while. It can take you a while here. It says, describe how you would use the names in a hat method to choose a simple random sample of 3 stores. Well, I would put all store names in a hat. I would shake it up. I would select 3 without replacement, and then I would survey those 3 stores and ask them what hours they would like to stay open during the holiday season. So the next way we could do it is also using our calculator. And I'll show you how to do that. All right. Now, if you have the same model as me, all right, if you have the TI-84 color edition, well, I'll just use a regular one because I'm almost out of battery. All right. So, first thing you have to do, just seed your calculator with a certain number, okay? So, for instance, here's the way I can see the calculator. If I go stat, that's not what I do, sorry. I go math, go over to probability, right. Actually, before we do that, just pick a number. So for instance, pick 10. Then hit the STO button on the bottom. Okay, this one right here. STO at the very bottom of your calculator, which stands for store. Okay. And now go math, go over to the probability section and choose option 1 for rand, and just choose that. All right, what I've actually done is I've seeded my calculator. Now, if you're using the same model calculator that I am, what I do next, you should get exactly the same listing. But here's how we can do this in the calculator. Here's how we can get random digits. You pick a number to seed, all right? And now you go math, go back over to probability, and scroll down until you see the option that says rand int no rep. What this stands for, I'm telling my calculator, choose a random integer with no repeats. Okay, random integer, no repeats. So you have to give the calculator a couple pieces of information on this model. All right, and I'll do it on the other calculator too, and it's almost out of battery power. All right, so let me kind of seed it the same way. 10, store, math rand. All right, and then I'll go math, probability, random integer, no repeat. All right, if you have the newer calculator, it gives you a menu. So it says, what's the low number? So our low number was 1. We started our numbers at 1 of our stores. We have 21 stores. And then it'll say n. How many do you want? I want 3 numbers. I'm going to paste. We do it over here the same way. We do 1 is our lower, but we have to put a comma, then 21, and I'm telling the calculator pick 3 of them. Okay, and I hit enter. This one gives me an error. So actually on the older model, you can only put a lower and upper bound, 1 to 21, and hit enter. All right, and it will give me a string of numbers. It will give me a string of numbers, 7, 13, 2. All right, those would be the first 3 of the string. On this model, it's not going to have that. It's going to give me 3 numbers here. It's just going to return 3. It's not going to return a whole string like this. All right, so if I'm using the newer model of the calculator, which is probably preferred, this is saying it's picking 3 of the numbers between 1 and 21, and it's not going to repeat any of them. So 10, 12, and 6. So if I use the newer model of calculator, I have store number 10, number 12, and number 6. So if I use my calculator, the newer model, you should get the same numbers as these if you seeded your calculator starting with the number 10. Okay, you had to do that first. All right, and those 3 stores, it corresponds to GameStop. That's number 10. Number 12 is Gymboree. All right, and number 6 was Destination Tan. Okay. So those would be the 3 stores if I use my calculator and seeded it with the number 10. All right. Now, if you hit it again, okay, if you do the same entry again, it's going to give you 3 different numbers. Okay. So it says here, just notes for you, it says be careful. Be sure that you pay attention to whether you are sampling with replacement or sampling without replacement. Without is the preferred method. Like here, it says select 3 without replacement. I'm going to take a name out of the hat, but I'm not going to put the name back in because I want 3 different stores. I don't want to pick Barnes and Noble, for instance, and then throw that name back in the hat and choose it again. That's why when like the number 4 came up again, I didn't select it again. That's without replacement. If it was with replacement, then I would ask them again, but I don't want to do that. When describing how to choose a sample, okay, be sure to address what you do with repeated labels. Like I did it here. Select 3 without replacement. That lets the reader know that you're taking a name out of the hat, but you're not putting it back in. In most cases, samples are taken without replacement. Therefore, you must indicate with words, okay, that repeated labels should be ignored. Now, the names in the hat method is usually the best way to get points on the AP test. Okay, you can do it very, very easily. If you talk about using a random number table, like up here, or using a random number generator on your calculator, you have to be very, very specific. It's harder to get the points there because your process is more lengthy on describing it. So we talked about a couple bad types of samples, convenient samples. We've had convenient samples. Those are bad. Okay, you have voluntary response samples, which are bad. Okay, we talked about simple random samples. That's good. That's usually the best. Okay, but there's a couple other types of samples. There's a stratified random sample, and there's a cluster sample. Okay, so it says to select a stratified random sample, first classify the population into groups of similar individuals called strata. Then choose a separate SRS in each stratum and combine these simple random samples to form the full sample. So as an example, in a high school, you might subdivide everybody into grade levels. So ninth, 10th, 11th, and 12th. You might have a listing of all freshmen, sophomores, juniors, and seniors in a high school. And maybe to make sure that we get some of each people, okay, maybe we could pick 5 freshmen, 5 sophomores, 5 juniors, and 5 seniors. So this assures with a stratified random sample, we're guaranteed that we're getting at least some people in each grade level. Okay, if this was a school of 300 people and I just picked 20 people at random, there's no guarantee that any of them would be freshmen. There's no guarantee that any would be sophomores, so on and so forth. So here we would put after we asked each of these 5 in each grade a question, we put them together and that forms our sample. So that would be an example of stratified. That's stratified sampling. All right. Now it says here, let's look at another type of sample, which is called a cluster sample. It says first divide the population into smaller groups called clusters. Ideally, each cluster should mirror the characteristics of the population. Okay. Then choose a simple random sample of the clusters. All individuals in the chosen cluster are included in the sample. So the way I like to teach students to think about cluster sampling, imagine you have the US. Okay, so I'm going to draw a really bad picture of the US. Okay, so there's the US. And in the US, we have 50 states. Okay, we have, Alabama down here. All right, you got the great state of Ohio up here. All right, you got California over here, Oregon, Washington. So what we could do, rather than asking all 320 million people in the US, we have a couple states here. So what we can do is we can put maybe all 50 state names in a hat, okay? And then we choose a couple out of the hat without replacement. All right, let's just say, for instance, we drew out Washington, we drew out Alabama, and we drew out Ohio. Well, we could just pick those 3 states and ask everybody in those 3 states a question. Okay, so if you think about each state has a wide mix of people, okay, in terms of races, in terms of religions, in terms of political leanings, okay, they're very diverse. So Ohio people are generally representative of the population. Alabama are representative of the population if we just looked at Alabama. If you just looked at Washington state, they're representative. They're very diverse. The people in each state are very diverse. Okay, just like the population of the country is very diverse. But we just pick a couple of these clusters. So Washington people are a cluster, Alabama people are a cluster, Ohio people are a cluster. And then we're going to just look at the responses of people in those 3 states, and that's going to form our sample. That's the best way I like to think about a cluster. Okay. Each cluster should mirror the characteristics of the population. We chose 3 states, 3 clusters out of 50 clusters. Okay. And all individuals in the chosen clusters, so all people in Ohio, Alabama, and Washington are included in the sample. Example 4, it says you want to take a survey of students from your high school. Describe how you would use each of the following sampling methods to select 100 students to complete the survey. So in a simple random sample, okay, you would put all student names in a hat. Okay, shake it up. Choose 100 names without replacement. And give the selected names a survey. That would be a simple random sample. A stratified random sample, okay, we're going to first subdivide each student by grade level. For each grade level, put all student names in a, for each grade level, put all student names in a hat, choose 25 names, because if I have 20, basically that was like the stratified up here. We have 9th, 10th, 11th, and 12th graders. All right, and then we're going to just take 25 out of each of them. We're going to pick 25 freshmen, 25 sophomores, 25 juniors, and 25 seniors. 9, 10, 11, 12. Okay. So we're going to choose 25 names without replacement in each grade level. And give the selected students the survey. All right, how could we make this work with clusters? All right, how could we make this by clusters? So we're going to arrange students by homeroom. That's one way. All right. Choose, arrange students by homeroom, and then we are going to put all homeroom teacher names into a hat draw teacher names. I could also say shake it up. Draw teacher names and sample all students in the selected teacher's homeroom until at least 100 students are sampled. Okay, so that's a little bit different. All right, we're not, because some homerooms might have 25 students, some homerooms might have 30 students, some homerooms might have 10 students. All right, but we're going to draw a teacher out. We're going to draw a teacher name out of the hat. We're going to ask all of his or her homeroom students their opinion. We're going to give them the survey. And then as soon as I get over 100 responses, I can stop. Okay, but I do need to ask everybody in that homeroom. All right, so like if I'm the teacher and I have 50 students in homeroom, and then another teacher's name gets drawn after that, and there's 50 students in her homeroom, then we can stop. Okay, then we can stop. So that's one way we could do a cluster sample in a school. All right, let's go to the last page of this section. Now, why do we do sampling? Okay, why don't we just ask everybody? Well, like I said, it's too costly and it takes too long. All right, so we're going to take a sample, and we're going to get some results from the sample, and that's going to let us draw inferences about the population. Okay, so for instance, we're going to take a sample of 100 students, and that's going to let us make guesses about the population of a school of, like, I don't know, maybe the school has, maybe the school has 1,000 students. So if we can ask 100 people and do our sampling right, then we can make generalizations about these 1,000 people. And that process, using these to make guesses about this, that process is called inference. And the whole second half of the book is devoted to inference. All right. Why is it called inference? Because we infer, which basically means make educated guesses. They're educated because they come from a sample, but we infer information about the population from what we know about the sample. All right. Now, why are convenient samples or voluntary response samples so bad? All right, because the results are misleading, because these methods of choosing a sample are biased. All right, they don't have randomness in them. All right, so the reason we use random sampling, this is very important, the reason we use random sampling is to reduce bias. We still might have bias even if we use a random process, but it does reduce bias. Okay. The laws of probability allow trustworthy inference about the population, and we'll get more into that in the second half of the book. All right. And what about another key part of this chapter? If we use a random sample, as long as it's fairly large, okay? So if we have a population of 300 million people, we shouldn't just ask 10 people. The number has to be bigger than that. But the larger our sample is, it gives us better information about the population than smaller samples. So here's some type of errors that we can get when we're sampling. Okay. Well, we have voluntary response error. Okay, that comes from using a voluntary response sample. All right, here's the big one that's really hard to avoid no matter whether you're using good sampling or bad sampling, this thing called undercoverage. Undercoverage occurs when some groups in the population are left out of the process of choosing the sample. So, for instance, if you want information about Americans and your method of choice to collect the data is by telephone calls, that suffers from undercoverage because you're leaving out everyone that doesn't have a telephone. Okay, well, then you might say, well, I'm going to mail stuff to them. Well, some people are homeless, so you're going to leave them out. All right, so undercoverage might exist and it might not even be intentional. All right, you can just undercoverage by the way you're sampling. All right, so know that type of error. All right, now that's a result of how you sample. That's why these things are called sampling errors. It's, errors you get from your sampling methods. All right. So this isn't an error. A sampling frame is not an error, but it's just another vocabulary term. It's a list of individuals from which we draw our sample. Okay. This list should consist of the entire population, but since a list of the entire population is rarely available, many samples suffer from some degree of undercoverage. So if I have a list of all citizens of the United States, that sampling frame would be a long list of about 320 million people. Okay, but even then, it probably doesn't have everyone. Okay, it's probably missing people. We probably missed some people. All right, now there's other types of errors that aren't associated on how you sample. All right, maybe your sample was really good. You still could have other type of errors. So non-sampling errors are errors that don't come from your sampling method. Okay, non-response error. Okay, so we choose somebody. All right, we choose somebody, but they can't be contacted or they don't want to participate in our sample. All right. Another type of error that we can get is response bias. We ask someone to participate in our survey and they agree, but they might not be telling the truth. All right. It says response bias could result from either an intentional or unintentional lie, the way we word a question, or the influence of the person asking the question. Okay, so let me give you an example of a response bias. If I wanted to take a sample as your teacher, and I asked you about drug use, okay, maybe I asked you a question, have you ever used marijuana? Well, you might not be telling me the truth because I'm in a position of authority over you. All right, so that's my influence by me asking you the question might lead you to lie. Okay. If someone else asked you that question that wasn't in an authority position, and they gave you methods to make sure your responses were anonymous, that would be more likely that you would tell the truth. Okay, so, or I could even, without wording of the questions, I could start if I'm going to take a survey of you, I could start with, don't you think that abortion is wrong? I could say something like that to make you try to think the way I think. All right, so that's the way a sample would suffer from response bias. So example 5, it says each of the following is a source of error in a sample survey. Label each as sampling error or non-sampling error and explain your answers. All right, so it says the telephone directory is used as a sampling frame. All right, so I'm going to use the telephone book for a list of people. What type of error would that have? Well, that would be an undercoverage error. Okay, that's an undercoverage error, which is a type of sampling error. All right, it ignores the people not listed in the phone book. Okay, so those would be the people without telephones or people that have paid to purposely not be in the phone book. All right, so the next one, it says the person cannot be contacted in 5 calls. Well, if they can't be contacted, then that would be a non-response error. You've done everything you could to contact them. All right, this is not associated with your sample, so this would be a non-sampling error. Okay, and they can't be contacted to participate. All right, and the last one, it says interviewers choose people walking by on the sidewalk to interview. Okay, so this is more of a convenience sample. Okay, that's a convenience sample. All right, so it would be a sampling type of error. Okay, you're making the choice who to interview, walking by on the sidewalk to interview. All right, and I guess you could kind of frame that as a voluntary response. Okay, a little bit of voluntary response there because people are if people are passionate about what you're asking them, they'll participate, and if they don't care either way, they're probably going to keep on walking by. Right, let's look at the last one. Example 6, it says a survey paid for by makers of disposable diapers found that 84% of the sample opposed banning disposable diapers. Here's the actual question. It is estimated that disposable diapers account for less than 2% of trash in today's landfills. In contrast, beverage containers, third-class mail, and yard wastes are estimated to account for about 21% of trash in the landfills. Given this, in your opinion, would it be fair to ban disposable diapers? Okay. Explain how the wording of the question could result in bias. Be sure to specify the direction of the bias. All right. So let's think about the wording here. It says that disposable diapers account for less than 2%. All right. So it's kind of a small percentage. In contrast, beverage containers, third-class mail, and yard waste are estimated to account for about 21%. All right. So they're making a comparison. All right. And then they're directing your attention to given this. Okay. So they want you to think about the numbers they just gave you. All right. 21% is, more than 10 times this. In your opinion, would it be fair to ban disposable diapers? They're trying to get you to answer a certain way based on 2 facts that they gave you. All right, so they're trying to influence your opinion. So the surveyors are trying to influence a response Okay, they're trying to influence your response. So what this is response bias. The people asking the question are trying to get you to answer a certain way on the way they framed the question. Okay. So it also tells me to specify the direction of the bias. This number is probably higher. Okay. The 84% is probably an overestimate on people's true opinion. All right, because when you hear things like that, you kind of want to say, since the surveyors are trying to influence the people asking you the question, they're trying to influence your opinion and say that we should not ban disposable diapers. That's what their goal is. They want you to answer that way. All right, they want you to oppose banning disposable diapers. That's the reason this is so high. It's because they're influencing the way you think. All right? Just the way television commercials try to influence the way you think. They want you to buy their products. So they're going to bring some numbers into play and make you think the way they want you to think. All right? So the 84% is probably an overestimate on people's true opinion on banning disposable diapers. It's probably lower. It's probably lower. Probably less people really oppose it. But the way the question's asked, they're trying to get you to answer a certain way. Right, so that's going to do it for this section for 4.1. Hopefully it all made sense. Just let me know if you have any questions about any of the topics presented in this lesson.